2014 Projectiles Question 3 Part B. Particle is projected up an inclined plane with an initial speed of u. The line of projection makes an angle alpha with the incline. Okay, so this one is alpha, speed of u, and beta to the horizontal. So beta is down here. We're told that the particle is moving horizontally when it strikes the plane. We had a couple of vertical ones where v of x is equal to 0. So v of y is equal to 0 when it strikes horizontally. So show that tan alpha is equal to tan beta plus 1 plus over 1 plus 2 tan squared beta. So let's start by setting up my accelerations. Minus g. The angle to the horizontal is in here, beta. So I have minus g cos beta. And I have minus g sine beta. So for the time of flight, we can use y to sine s of y is equal to 0. So my velocity for y, write down to begin with, u cos alpha times I plus u sine alpha times j. So we're using our u sine alpha. So ut plus a half at squared, we have our a's, is equal to 0. So u sine alpha times t. My acceleration in the j direction is g cos beta. So minus g cos beta over 2 times t squared is equal to 0. So factor out my t, and I'm going to get u sine alpha minus g cos beta times t over 2 is equal to 0. So this is my initial time at 0, and u sine alpha would have to be equal to g cos beta times t over 2 for this to be equal to 0. So 2u sine alpha, and we're dividing across by g cos beta, is the time it takes to get to wherever it's going to strike. I'll do it here. So to here. So that's the time taken to get to here. If I do this, it lands horizontally. That angle is also, that's supposed to be a beta. Let me put that in. That angle is beta. If we get the two velocity vectors, we can apply the tan of the landing angle is minus the velocity of y over the velocity of x, or minus the velocity of j over the velocity of I. So maybe that's the best way to approach this question. We get the velocity in the I direction. It's equal to u plus at. We have our a is minus g sine beta, and we have our u is u cos alpha. So we could have this u cos alpha, my acceleration is minus g sine beta, and my time is 2u sine alpha over g cos beta. What's this going to give me? It's going to give me u cos alpha. Sine over cos is tan, so I'll change this one to tan. If we do anything else, the g's cancel, so that's tan beta, and we do want tan beta in our answer, so that this is going to give me minus 2u sine alpha tan beta minus 2u sine alpha tan beta. That's the vector in the I direction and the velocity of it. So if we look at the same in the j direction, u plus at, so my initial velocity u sine alpha and minus g cos beta for acceleration, u sine alpha minus g cos beta times time, 2u sine alpha over g cos beta. So we can see these g cos betas are going to cancel, and we're left with u sine alpha minus 2u sine alpha. Well, they're the same. They're like terms. So that's just going to be minus u sine alpha. And the landing angle, so we have our v of I and our v of j. So the landing angle, if it's horizontal, as we said, that's going to be the b in there, and it's landing at this angle. So minus the velocity of j over the velocity of I is equal to that landing angle, or the tan of that landing angle, the tan of beta. This should help us get to the solution. So we're going to have minus this guy, which is just u sine alpha, over u cos alpha minus 2u sine alpha tan beta has to be equal to tan beta. Let's have a quick look at what they're looking for. They want us to show tan alpha tan beta 1 plus 2 tan squared beta. So we need to get rid of these sines and causes. So we want it all in tan. So it should jump out at you that to get tan here, we'd have to divide that by u cos alpha. So if we divide everything by u cos alpha, we're going to get u sine alpha over u cos alpha. That's going to give me tan alpha over u cos alpha over u cos alpha minus 2u sine alpha tan beta over u cos alpha should enable us to simplify everything down here. We're going to get tan alpha on top. On the bottom, we're going to get 1 minus 2 tan alpha tan beta. So we have everything in terms of tan, and that's equal to tan beta. So what are we looking for? Tan alpha is equal to tan beta over 1 plus 2 tan squared beta. So we're not quite there yet. So let's multiply this out. So we're going to get tan alpha is equal to cross multiplying tan beta minus 2 tan alpha tan squared beta. And if we bring the tan alpha to the left, we're going to leave this tan alpha here, bring the other one across, plus 2 tan alpha tan squared beta equals tan beta. We can factor out tan alpha to leave 1 plus 2 tan squared beta equals tan beta, and we were asked for tan alpha equals, weren't we? Tan alpha is equal to the tan of beta divided by 1 plus 2 tan squared beta. Is that what they were looking for? Tan beta over 1 plus 2 tan squared beta. Tan beta over 1 plus 2 tan squared beta. The final part of this question, you're asked to hence or otherwise show that tan alpha is less than tan beta. Okay, but tan alpha is equal to this whole thing on the right. This is greater than 0. So the bottom is greater than 1. So we can say if the bottom is greater than 1, we can say that tan beta would reduce the value of tan beta. If tan beta was 5, it would reduce it to less than 5 because we're dividing by a number greater than 1. So 1 plus 2 tan squared beta, tan beta over 1 plus 2 tan squared beta is less than tan beta because we're reducing the value of the top by dividing by a number greater than 1. So tan alpha is equal to this, which is less than tan beta. Therefore, tan alpha has to be less than tan beta.